Dear students, I am happy to meet you again. Today here we are going to revise the 2 marks of Unit 1 Introduction to Power Quality. So in the last session we just discussed in detail about the various topics related to Introduction to Power Quality. Here just we are going to discuss about the 2 marks. So here we are going to discuss about the various possible 2-mark questions. First one is define power quality. So power quality problem is basically identified by the changes that occurs in the voltage and current waveform. The second important question is that they may ask the different types of power quality problems. What are the power quality problems? Sag, swell, interruptions, under voltage, over voltage, transients, harmonics, voltage flickers. Next one is what are the various classifications or categories of power quality? So we can broadly classify it as transients, short duration variation, long duration variation, waveform distortion, voltage fluctuation and power frequency variation. Then they may ask what are the types of transients? Impulsive transient, oscillatory transient. So in oscillatory transients we have 3 types. One is low frequency oscillatory transient, medium frequency oscillatory transient and high frequency oscillatory transient. Next, what are the various types of short duration variations? Interruptions, sag, swell. Similarly, long duration variation, it may be sustained interruption, over voltage, under voltage. Next question is what are the various types of waveform distortions? First one, DC offset, harmonics, interharmonics, notching and noise. Next, they may ask the various definitions of various power quality problems. So in order to simplify the study, instead of giving us questions, here I have given it as a table for each and every type of power quality problem, and here I have mentioned the definitions. From the table itself you will be able to write. For example, if you consider the impulsive transient, define impulsive transient. So impulsive transient is a sudden non-power frequency change in the steady state condition of voltage or current or both, that is unidirectional in polarity. Similarly, from the table itself you will be able to write all the 2-mark questions. So here this table is shared in the Google Classroom. So here this is the table for the entire type of power quality problems. Similarly, in the case of the categorization, they may ask for the various categories. With they may ask the spectral content or duration or voltage magnitude. Similarly, they may ask the causes. For answering this type of questions, here I have formed another table. One is the spectral content, duration, voltage magnitude and the causes. Okay. So here from this you can also write the various classifications, and here you can also be able to write the definitions for a specific type of a power quality problem. For example, if they ask for a low frequency oscillator transient, so the oscillator transients whose frequency is less than 5 kHz, they are called to be as a low frequency oscillator transient. So here I have specified the duration as well the voltage magnitude for it. So from the table you can get a clear picture how to write it. Similarly, here the last column of this table comprises of the causes. So the one of the expert question is they may ask what are the causes of each type of a transient or the power quality problem, right? So for example, what are the causes of impulsive transient? Here the cause is lightning. Similarly, for low frequency oscillator transient means here you can write from the table capacitor bank energization, interruption of short circuits and equipment failure. Likewise, from this particular table you will be able to write any cause for a particular problem. So here up to this we have discussed what is power quality problem, what are the various classification, the definitions of each type of power quality problem, then the spectral content, duration and voltage magnitude of each type of power quality problem. Similarly, the causes of each type of power quality problem. So from this content you may expect minimum of one question. Next one is the important question is they may ask to draw the CBMA curve. So it is a frequently asked question. So here I have given you a clear picture of a CBMA curve. So the rating, the values of the x-axis and y-axis are more important. You have to draw it accordingly, right? Next one is what are the various international standards of power quality? So IEEE, IEC, CENILEC, ANSI, NER, SEMI and UAE. So these are the various international power quality standards. So they may ask specifically, they may ask what is IEEE standard or IEC standard, CENILEC likewise. So here I have been given the expansion for it. Next curve is the ITAC curve. So here in the ITAC curve, here we can expect three questions. One is draw the ITAC curve. Second one is uses of ITAC, similarly advantages. So when it comes to uses of ITAC curve, it can be applied to general power quality evaluation. So though it is being developed for a 120 volt equipment, we can use for any power quality evaluation. Next one is it is used as a reference to define the withstand capacity of various loads. Okay. So next one, when it comes to advantages, it has an expanded acceptable power area or operating region. Similarly, here in the case of ITAC curve, the area is represented in a more simpler manner. Right. Next one is it describes both the steady state condition and the transient condition. So here this is what your ITAC curve. So if you have been asked to draw the ITAC curve, so you have to draw the curve accurately. So here when you consider this particular x-axis, it will be represented with two scales. One is with the seconds and next one is with the cycles. Both has to be represented properly. And the regions has to be mentioned clearly. So when you consider what are the important IEEE standards. Okay, so these are some of the important IEEE standards. IEEE 519, IEEE 1159, IEEE P1564, IEEE P1453, IEEE 1346, IEEE P1100. So these are the important IEEE standards. So these are the most expected questions regarding this unit 1 of the power quality. So in the last session we discussed about three important 13-mark questions which can be asked. One is the various classifications of power quality. Second one is explain the international standards of power quality. Next one is explain the CBMA curve. So this is what about unit 1. Thank you. All the best.